Why do people use CPUs for high-performance computation instead of a more specialized chip? From my understanding, people began using CPUs for general computing because they are an extra source of computing power. And though they are not as fast as a CPU for each operation, they have many cores, so they can be better adapted for parallel processing than a CPU. This makes sense if you already own a computer that happens to have a GPU for graphics processing, but you don't need the graphics, and would like some more computational power. But I also understand that people buy CPUs specifically to add computing power, with no intention to use them to process graphics. To me, this seems similar to the following analogy. I need to cut my grass, but my lawn mower is wimpy. So I remove the cage from the box fan I keep in my bedroom and sharpen the blades. I duct tape it to my mower, and I find that it works reasonably well. Years later, I am the purchasing officer for a large lawn care business. I have a sizable budget to spend on grass cutting implements. Instead of buying lawn mowers, I buy a bunch of box fans. Again, they work fine, but I have to pay for extra parts, like the cage, that I won't end up using. For the purposes of this analogy, we must assume that lawn mowers and box fans cost about the same. So why is there not a market for a chip or a device that has the processing power of a GPU, but not the graphics overhead? I can think of a few possible explanations. Which of them, if any, is correct? Such an alternative would be too expensive to develop when the GPU is already a fine option. Lawn mowers don't exist, why not use this perfectly good box fan? The fact that G stands for graphics denotes only an intended use, and does not really mean that any effort goes into making the chip better adapted to graphics processing than any other sort of work. Lawn mowers and box fans are the same thing when you get right down to it. No modifications are necessary to get one to function like the other. Modern CPUs carry the same name as their ancient predecessors, but these days the high-end ones are not designed to specifically process graphics. Modern box fans are designed to function mostly as lawn mowers, even if older ones weren't. It is easy to translate pretty much any problem into the language of graphics processing. Grass can be cut by blowing air over it really fast. Edit. My question has been answered, but based on some of the comments and answers, I feel that I should clarify my question. I'm not asking why everyone doesn't buy their own computations. Clearly that would be too expensive most of the time. I simply observe that there seems to be a demand for devices that can quickly perform parallel computations. I was wondering why it seems that the optimal such device is the graphics processing unit, as opposed to a device designed for this purpose.
It's really a combination of all your explanations. Cheaper and easier already exists, and design has shifted away from pure graphics. A modern GPU can be viewed as primarily stream processors with some additional graphics hardware, and some fixed function accelerators, for example for encoding and decoding video. GPU programming these days uses apps specifically designed for this purpose. OpenGL, NVIDIA CUDA, AMD app. Over the last decade or two, GPUs have evolved from a fixed function pipeline, pretty much graphics only, to a programmable pipeline. Shaders let you write custom instructions, to more modern apps like OpenGL that provide direct access to the shader cores without the accompanying graphics pipeline. The remaining graphics bits are minor. They're such a small part of the cost of the card that it isn't significantly cheaper to leave them out, and you incur the cost of an additional design. So this is usually not done. There is no compute-oriented equivalent of most GPUs, except at the highest tiers, and those are quite expensive. Normal gaming kits are very commonly used because economies of scale and relative simplicity make them cheap and easy to get started with. It's a fairly easy path from graphics programming to accelerating other programs with gpgpu. It's also easy to upgrade the hardware as newer and faster products are available, unlike the other options. Basically, the choices come down to general purpose CPU, great for branching and sequential code. Normal gaming gpgpu. Compute-oriented gpgpu, for example NVIDIA Tesla and Radeon Instinct. These often do not support graphics output at all, so gpgpu is a bit of a misnomer. However, they do use similar gpgpu cores to normal GPUs, and OpenCL/CUDA/app code is more or less directly portable. FPS, which use a very different programming model and tends to be very costly. This is where a significant barrier to entry exists. They're also not necessarily faster than a gpgpu, depending on the workload. ASICs, custom designed circuits, hardware. This is very expensive and only becomes worth it with extreme scale. We're talking many thousands of units, at the very least, and where you're sure the program will never need to change. They are rarely feasible in the real world. You'll also have to redesign and test the entire thing every time technology advances. You can't just swap in a new processor like you can with CPUs and GPUs.
My favorite analogy. CPU, a polymath genius. Can do one or two things at a time, but those things can be very complex. gpgpu, a ton of low-skilled workers. Each of them can't do very big problems, but en masse you can get a lot done. To your question, yes, there is some graphics overhead, but I believe it's marginal. ASIC/FA, a company. You can hire a ton of low-skilled workers or a couple of geniuses, or a combination of low-skilled workers and geniuses. What you use depends on cost sensitivity, the degree to which a task is parallelizable, and other factors. Because of how the market has played out, GPUs are the best choice for most highly parallel applications, and GPUs are the best choice when power and unit cost are the primary concerns. Directly to your question, why a GPU over an ASIC/FA? Generally cost. Even with today's inflated GPU prices, it is still, generally, cheaper to use a GPU than designing an ASIC to meet your needs. As at user 912264 points out, there are specific tasks that can be useful for ASICs/FAS. If you have a unique task and you will benefit from scale, then it can be worth it to design an ASIC/FA. In fact, you can design/buy/license FA design specifically for this purpose. This is done to power the pixels in high-definition TVs, for example.
Your analogy is bad. In the analogy, when you're buying equipment for a large lawn care business, you assume there are good lawn mowers available. This is not the case in the computing world. GPUs are the best tool readily available. The R&D costs and possible performance gains for a specialized chip are likely too high to justify making one. That said, I'm aware of NVIDIA putting out some GPUs specifically for general purpose computing. They had no video outputs, a bit like selling box fans with the cages already removed.
Of course, you can use specialized chips, either for energy efficiency or calculation speed. Let me tell you the history of Bitcoin mining. Bitcoin is new, geeks mine with their GPUs. Bitcoin is somewhat new, smart geeks mine with their GPUs. Bitcoin is now, kinda, famous, people buy FCAS. Bitcoin is now famous, 2013, even newbies buy ASICs, application-specific integrated circuits, to mine efficiently. Block reward drops, periodically, even old ASICs are not profitable anymore. So no, there are no reasons to use a coup instead of a specialized giant calculator. The bigger the economical incentives, the more the hardware gets specialized. However, they are quite hard to design and infeasible to manufacture if you're not producing thousands at once. If it's not viable to design chips, you can buy one of those from the nearest Walmart. TL. Doctor, of course you can use more specialized chips.
Computation.